That box sitting in your kitchen never actually cooks your food from the inside out. Every single time you've heard that, you've been told something that just isn't true. And the thing that actually heats up your food is so strange that once you get it, you'll never look at your microwave the same way again. A plate spins around, there's this soft humming sound inside, and in about 30 seconds, your cold food is steaming. But there's no fire in there, there's no glowing hot coil. So where is all that heat actually coming from? Today, I'm going to answer 4 questions, and I'm saving the last one for the final 30 seconds of this video. 1. If it doesn't cook from the inside out, then how does it actually work? 2. This thing gives off radiation, so is that actually dangerous for your body? 3. Why do you even need that spinning glass plate inside? And 4. Why does it suddenly throw sparks the moment you leave a spoon in there? I'll be honest, I used to think this machine zapped all the nutrition right out of my food. You've probably reheated coffee before, where it looks totally calm until the second you grab the cup, and then it suddenly bubbles up and spills everywhere. Or one side comes out scalding hot, while the other side is still ice cold. Hidden behind those little everyday annoyances is the whole science of how this works. To really get this, I want you to picture something in your head. A packed dance floor. Thousands of people crammed inside. Now a DJ starts playing a beat that tells everyone to spin around and face the opposite way 2.45 billion times every single second. Nobody can keep up. Everybody starts crashing into each other. And all that bumping and rubbing heats the whole room up. That's exactly what happens inside your microwave. Except the dancers are the water molecules in your food. But who's actually playing this impossible beat? Here's where we need a little real science. Your food is packed with water, and every water molecule is basically a tiny magnet, positive on one end and negative on the other. Microwaves are electromagnetic waves, sitting right between radio waves and infrared on the spectrum. A home microwave oven runs at about 2.45 gigahertz, which gives it a wavelength of roughly 12 centimeters. And this number is the same everywhere you look, from the FDA to Vollmer's physics research to Baldwin's paper. The electric field of this wave flips its direction 2.45 billion times a second. Each water molecule tries to twist itself to line up with that field. When the field flips up, the molecule turns. When it flips down, the molecule turns back, again and again, with no chance to ever stop. That frantic twisting creates friction, and that friction is your heat. It's that simple, and it's that strange. But what machine is actually making these waves? The answer is a little metal tube called a magnetron. It was invented back in 1921 and refined so much around 1940 that it changed both wartime radar and your kitchen forever. Inside it, a hot filament shoots out electrons and magnets bend them so they whip past a bunch of little cavities. Just like blowing across the top of a bottle makes it whistle, those swirling electrons make microwaves. Then a waveguide hidden inside the wall pushes that energy straight towards your food, and the whole metal box acts like a cage, trapping the waves inside. And this is exactly where that spark mystery comes in. Metal doesn't absorb microwaves, it reflects them like a mirror. On the sharp edges of a spoon or some foil, electricity builds up and jumps as a spark. And that spark can actually start a fire. So, if metal reflects the waves and food absorbs them, which part of your food actually heats up first? This is where the biggest myth of all falls apart. A microwave does not cook from the inside out. The FDA says it clearly. The waves are mostly absorbed in the outer couple of centimeters where they create heat, and the very center warms up the old-fashioned way, slowly through conduction. So why does it feel so fast? Because unlike a stove, it doesn't just heat one surface and wait for it to work its way in, it heats that entire outer volume all at once. And that's the exact reason you never get a crispy crust. There's no hot, dry air inside, so a crust never forms. That's why some frozen foods come with a little foil and cardboard sleeve which heats up in the microwave and crisps the outside of your food. But if the heat spreads evenly through your food, then why does one side burn while the other stays cold? By now, you might be thinking, okay, mystery solved. Water's a magnet, the waves spin it, friction makes heat, end of story. You could close this video right now and go show off to a friend. But hold on, because this is where the really weird part actually begins. Because this machine literally can't heat your food evenly, and the reason why is hiding right underneath that spinning plate. As the waves bounce off the metal walls over and over, they overlap with themselves and create what's called a standing wave. In some spots, you get the peak of the wave, and in others, you get almost nothing. The peaks get blazing hot, while those dead spots stay barely warm. One engineer once laid down a slab of cheese and showed that some parts melted while others stayed totally cold. And the melted stripes were about 2.5 inches apart, which is exactly half the wavelength. Those hot and cold patches are the whole reason that spinning plate exists. It drags your food through those hot zones so the heat evens out at least a little. Quick tip. Put small items near the edge of the plate instead of dead center, because that's where they move around the most. But that word radiation is what really scares people, right? Is it actually damaging your body from the inside?
Take a breath, because the truth here is a relief. Microwaves are non-ionizing radiation, just as harmless as visible light and radio waves, nothing like X-rays or gamma rays. A single one of its photons carries roughly 1/1,000,000th of an electron volt, which is far too weak to break a chemical bond or ionize an atom. Meaning your food never becomes radioactive and it doesn't get chemically changed either. And safety? FDA rules say that 2 inches from the oven, it can never leak more than 5 milliwatts per square centimeter over its entire lifetime, and that drops off fast as you step away. Honestly, people have made money for years by scaring you about this machine, and it wouldn't be fair to call that fear completely fake either, because there's a real risk if you use it the wrong way. Every oven has 2 separate interlocks, so the moment you open the door, it stops making waves. Most injuries actually come from plain old heat, like super hot water suddenly erupting, which you can avoid by stirring in a pinch of coffee or sugar before you heat it. All those viral posts and forwarded messages telling you microwaves cause cancer, not a single one of them has any real science behind it. And nutrition? Harvard Health says the exact opposite is true. Less time and less water actually means things like vitamin C and the glucosinolates in broccoli survive better than they do when you boil them. This machine isn't killing the nutrition. A lot of the time, it's actually protecting it. So what did that crowded dance floor teach us in the end? Remember that dance floor? That crowd forced to spin around 2.45 billion times wasn't magic, and it wasn't some curse either. It was just friction, physics, and some brilliant engineering. The microwave is nothing to be afraid of. It's actually one of the cleverest and most underappreciated machines we've ever built. Now, let's finally close that last loop from the start of the video. By now, you know why a spoon throws sparks, why the plate spins, why the radiation is safe, and why it doesn't cook from the inside out. But the real question now goes to you. Have you spent your whole life believing microwaves ruin your food's nutrition, or did you always know it was safe? And if it really is this safe and this effective, then why are so many people still scared of it today? Is it the science or just old habits? Who's really to blame? Drop your side in the comments below and stick around on Science Dissect, because next time we're dissecting another machine you use every single day but have never really understood.